Hello, everybody. Hopefully you're having fun at middle school day. Ooh, the 6th grade first day, induction. All right, so this is reviewing this decimal addition and subtraction. It looks like the way it's lined up in the example that they have here, they'd like us to do the standard algorithm. If you changed it like you did, take and add, take and give and take, if you did that to set up the problems easier, great. Specifically, maybe this one, there might be something you could do there. Whatever. So whatever strategy you use, great. I am going to follow their lead here, at least for this one down here. We'll see what happens. So with that standard algorithm, they've already lined it up for us. That's the most important thing when it comes to adding and subtracting decimals. You got to make sure that this decimal point is lined up because it's all about place value. Got to respect that place value, and the decimal is always between the ones and the tenths. Always, 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 no matter what we do. It's always between the ones and the tenths. So having adding things up, looking through these problems, you see this space here where there's nothing. Well, guess what there is there? There's a 0. So anytime I see that space, I like to put a 0 in there just to remind me that's what I'm looking for. Because a lot of times people will adjust this. They'll move this whole number down, and they'll do 7.63, and then they'll do 3 plus 2 is 5, and that's way wrong. So we don't do that. There's zeros everywhere. Okay, there's zeros here for infinity. There's zeros to the left of the 7 for infinity. These are just the only place values that have digits in them in this number. Everything else has 0 in it. Every. All right, so we start at the right of the number. We go from the least place value to the greatest. So we're starting here in the thousands. Okay, so we have 7. This number is 4 and 67 thousandths plus 3 and 290 thousandths. They didn't have to put this 0 here, but they were kind to us this first time. So here we go. 7 plus 0 is 7. 6 plus 9 is 15. 1, if you struggle with that, I mean, you can think of this, you can make this 10 and this 5, right? Always got to remember to bring that 1 over. Now we have 1 plus 0 plus 2 is 3. We have to bring down this. Oh, I did the cardinal sin. I didn't make an estimate. So I like to round when I do this. So 4 plus 3 is 7. So my answer should be around 7. A little bit more than 7. And then we have 4 plus 3 is 7. 7 and 357 thousandths is the correct answer. All right, moving on. So let's first make our prediction. I see 1. That's almost 1.5 or 1.5 plus 1. So my answer is going to be around 1.5. 7 plus 2 is 9. 3 plus 4 is 7. 4 plus 0 is 4. Bring down that decimal point. 1 plus 1 is 2. Oh, did I say 1.5? What did I say? I should have said 2.5. Did I say 1.5? I don't know what I said. Maybe I should write it next time. Mr. Light, yeah. And maybe write this neater. So that's a 4. Okay, so we have 7 and 630 thousandths. We have that 0. Plus 4 and 592 thousandths. So if I round this is 8, 5. So I'm going to be around 13. I think it's going to, should it be a little less? It should be less than 13. So it's going to be less than 13. So let's see how this goes. 0, and why do I want to make an estimate? Well, a lot of times when we use the algorithm, we're not thinking, right? We're just responding to it. So if you do some thinking first and you put some thought down, it might help you if things go horribly wrong. 0 plus 2 is 2. 3 plus 9 is 12. Got to carry that 1 up here. 1 plus 6 is 7. Plus 5 is 12. Got to carry that 1 up here. 7 plus 1 is 8. Plus 4 is 12. Look at that. That's a cool problem. 12 and 222 thousandths. And that's less than 13. It's around 13. Alright, next one. We have 4 and 803 thousandths plus 1 and 420 thousandths. They put that 0 there. I wonder why they didn't put the 0 here. And they did. Interesting. So we got close to 5 plus 1.5. So my answer is going to be around, what, 6.5? It's going to be around that. Probably a little less, I would think, maybe. Let's see. 3 plus 0 is 3. 0 plus 2 is 2. 8 plus 4 is 12. Man, they like those 12s. Drop that decimal point down. And carry that 1. See, that there, if you got, like, I almost forgot to put the 1 up there. Because I didn't put it. I should have probably put the 1 up there and then the decimal point. But here, if we have to carry a number, so if right before, if in our tenths we have that 12, we have a multi-digit number. that might prevent us from bringing that decimal point down. So if you're struggling with that, one thing you can do is just, once you start, just put the decimal point down. But maybe that's the first thing you do, because the decimal point is going to be there every single time. So we have 1 plus 4 is 5 plus 6. So 6 and 223 thousandths. Now, what would be nice, if I did make that mistake where I wasn't paying attention and I got distracted because of the decimal point and I forgot to put the 1 up there and I got 4 plus 1 is 5, I would have looked at my estimate and looked at my answer and 5 and 2, what did I do wrong? Very important thing. So maybe I should have just modeled that, but sometimes I forget to just purposely make mistakes. All right, so we have 2 and 45 hundredths plus 1 and 469 thousandths. Do I want to make any changes? Doesn't look like anything too particular would help me out. So I'm just going to line this up. So I have 2 and 45 thousandths. I'm going to go ahead and make, or 45 hundredths. I'm going to make it 450 thousandths. 1 and 469 thousandths. So again, if you lined it up, hopefully you lined it up correctly. If you just did this, this is a very common mistake. And then you're like, oh, it's 9, 6, 4, 1. Okay, this is the wrong way. And the reason you know it's the wrong way is the decimal points don't line up. Okay, over here 0 plus 9 is 9. 5 plus 6 is 11. 1 plus 4 is, oh, I didn't estimate. 2.5 plus 1.5, what is that? About 4. So I'm going to get around 4. 1 plus 4 is 5 plus 4 is 9. Drop my decimal point down. 2 plus 1 is 3. 3.9, 3 and 919 thousandths is right around 4. So, job well done. And then we have 3-ish plus 1.5. So I'm going to be around 4.5. Let's line this up. 3.43 3 and 43 thousandths plus 1 and 588 thousandths. 3 plus 8 is 11. Carry that 1. 1 plus 4 is 5. Plus 8 is 13. Carry that 1. 1 plus 0 is 1. Plus 5 is 6. Drop down my decimal point. 3 plus 1 is 4. It's around 4.5. So I have 4 and 631 thousandths and 3 and 919 thousandths. Okay, subtraction. Yeah. So let's subtract. Again, a lot of times they purposely kept things in the middle to make it a little bit harder. I do, whenever possible, try to make 9s up here. But I don't know if we... And that way you would keep the same distance. So in subtraction, like in addition, it's give and take, right? So you give one, you take from one number and give to the other. Here it's constant difference. So if I wanted to drop this to 1 and 999 thousandths, I would be taking away 406. I would need to take away 406 here, which just, I mean, it's basically doing the subtraction anyway. So I'm just going to do the algorithm, just like they showed. Again, want to make some estimates. So this is around 2.5. This is around 0.5. So my answer is going to be around 2. 5 minus 2 is 3. 0 minus 1, got to borrow. 10 minus 1 is 9. 3 minus 5, nope. Make that 13. 13 minus 5 is 8. And then 1 minus 0 is 1. So that is 1 and 893 thousandths, which is around 2. Here I have 3.5 minus 2, which would be, what, about 1.5? Alright, 7 minus 6 is 1. 3 minus 0 is 3. 4 minus 1 is 3. Drop the decimal point, and 3 minus 2 is 1. So that's around 1.5. So I feel pretty good about that. Okay, if I make mistakes, let me know. I'm not perfect. It could happen. And I'll just say, oh yeah, I did that on purpose. So if you see you were paying attention, I didn't do it on purpose. Alright, I have about 5 minus 3.5, so that's going to be around 1.5, right? Yeah. 6 minus 0 is 6. 2 minus 4, I'm going to need to borrow my group of 10 here, so to make this 12. Minus 4 is 8. Drop the decimal point down. 4 minus 3 is 1. So 1 and 86 hundredths, that's around 1 and 5 tenths. 4 and 513ths minus 1 and 300, or 513 thousandths, minus 1 and 382 thousandths. That's about 4.5 minus 1, which is about 3.5. So 3 minus 2 is 1. 1 minus 8, we got to borrow that group of 10 from our neighbor next door. 11 minus 8 is 3. 4 minus 3 is 1. Drop that decimal point down. 4 minus 1 is 3. That's around 3.5. Did I make a mistake? Should I have made a better... Well, I guess if I just saw 1.5 minus 1.3, it should be around 3.2, which, yeah, it is. Okay. So we have 5 and 604 thousandths minus 3 and 25 thousandths. What if I were to... No, I would want my 9s up here. No, if I added up here, then I would have to add down there. Yeah, let's just do it. Okay, so 4 minus 5, we need to make this 14, but right here there's 0 in the place value, so we can't borrow a 10 here because we have a 0 there. So we need to borrow from our 6, who's in the hundredths. So that changes to 5. So this changes to 10. Then we got to borrow from this, so that changes to 9, and this gives us the 14. So 14 minus 5 is 9. 9 minus 2 is 7. 5 minus 0 is 5. Drop that decimal point down. 5 minus 3 is 2. Oh, I forgot to make my 5.6 minus 3, so about 2.6. Yep. Alright, so yeah, if you forget to do your estimate, just remember at the end. It's okay. 6 and 45 thousandths minus 2 and 39 thousandths. Ooh, I did not do a good job setting that up. Did you see that? Like it was all cattywampus. Don't do that. Make life confusing. We got to borrow right out of the gate. 15 minus 9 is 6. 3 minus 3 is 0. 0, 0, and 4. I didn't do my estimate again. This is basically 6 minus 2 is 4, and that's pretty much 4. Circle the pairs of numbers whose sums are greater than 2. Alright, so we have 1.2 plus 7. Ooh, that's close, isn't it? Maybe 3, 13. Yep. Well, I guess 2, 5 plus 0.75 would be 2, so those are both greater. So we have 2, 5 plus 0. No. We have a half, so we would want to get, this is 0.03 greater than a half, so this would need to be 0.03 less than a half, and it's 0.05 less, so this is a no-go. And then we have 1.5 plus 0.6, yeah, that'll be it. There you go. Alright, ciao.